In this video, we're going to look at graphs of exponentials. So we've just been studying compound interest and depreciation and looking at just the general exponential functions. So now let's have a look at what it looks like in graphic form. I'm going to use GeoGebra to help me, but I do want you to make notes because it's very important that you write down each transformation for each graphs. So any function in the form of y equals ax is an exponential function. So what I'm going to do is just show you what a basic exponential graph looks like. So this is when a, our growth factor, is greater than 1. So we call that an increasing exponential function. Now I want to just show you some key features. As you can see, this is a general shape, so it's a curve that's going up. And the main reason I've shown this crossover here is because the y-intercept is 1, and that's because if you think about when x is 0, anything to the power 0 is 1. There is also something called an asymptote at y equals c. Now I'll talk about what that is in a moment. The domain and the range are values, so the domain are all the x values that work for this function, and r is a symbol that we use for real numbers. So all the real numbers that we understand will work for this function. The range, and that's all the y values that work for this function. So currently this is only above 0, and I'll show you why in a second. So I talked to you about how the range is greater than 0. So let's just pick any x value that could go into this function. So let's pick, I don't know, 2 to the power negative 2. So we know from our laws of indices that 2 to the power negative 2 is 1 over 2 squared, which is 1/4. So even when x is negative, y is still above 0. Let's pick a fraction. Let's pick 2 to the power, or let's go with 4 to the power a half, because 4 is easy. 4 to the power a half is the same as the square root of 4, which is 2. Again, even when we put fraction numbers in here, y is still a positive number. It doesn't matter what value of x we put in there, y will always be above 0. It will never reach 0. There's no number that we can put in here for any base and any power that will give us 0. So we say that the asymptote is an imaginary line. So in this case, it's the x-axis where our function will never reach. So it's an imaginary line where the function tends towards, but it never ever reaches. So for this graph here, I've used a as 2 and obviously to the power x. So you can see here that this is the graph of y equals 2 to the power x, and you can see that it's increasing up here, and you can see that the y-intercept is 1, and you can also see that it tends very, very, very close to 0, but it never reaches 0. So this x-axis here is an imaginary line called an asymptote. Now let's have a look at changing around some of these. I'm going to show you a reflection now. So that means that when the x value is negative, so I'm going to do y equals 2 to the power negative x. Well, that shows a graph going in the other direction. You see the blue line, it's now a reflection in the y-axis. And we'll make some notes on that in a moment. Okay, so now what I'm going to do is show you how we do a reflection in the x-axis. So I'm going to put in the function y equals negative 2 to the power x. And you can see now this line going down, this is a reflection of the line above in the x-axis. So just moving back to our notes, this is generally associated with exponential decay. So I want you to take a moment and write those down, please. I'm now going to move on to show you what the graph looks like, horizontal translations of this graph, So what happens is this graph can also move left and right. So I'm going to just create a slider in GeoGebra to show you that if I change the function. So currently I've put y equals 2 to the power x plus 1. So well, x plus b, where b is 1. So you can see that's this grey line here. Now as I make b greater, the graph moves to the left. Notice how that y-intercept is no longer at 1. And if I make b less than 1, it then goes below. So you can see it's going over that side. And as b gets less and less and less and less negative, it moves to the right. So I've just written a little sketch here and some notes. I would like you to pause the video and make notes of this, please. And again, I'm going to move on to a vertical translation now. So this is where the graph moves up and down. So I'm going to put a slider in again. So I'm going to do graph y equals 2 to the power x. And then I'm going to add a c. Hopefully that'll work. And I will create the slider for c. So what you can see is the current graph is 2 to the power x and it's moved up one place. Now as I make c positive, you can see that y-intercept changes as it goes up. So it's a vertical translation, and of course same back the other way. If I make c negative, it goes down. It's called a vertical translation. So again, what I'd like you to do is make some notes on vertical translations by pausing the video. Okay, I'm going to run straight into an example now where we are going to find the equation of the asymptote and the y-intercept, and we're going to then sketch the graph of y equals 2 to the power x plus 3 minus 5, and we're going to state its range for that graph and the domain. So firstly, we'll just look at the equation and we can identify that it's an exponential and it's to the base 2. X plus 3 is the power. That means there's been a horizontal translation of the graph, and the fact that the whole graph is minus 5, that's a vertical translation of 5 places down. Now when we find the y-intercept of any graph, we always substitute x equals 0 into the equation. So just having a look here, if I sub 0 in there, I get y equals 2 to the power 3, which is 8, take away 5, which is 3. So our y-intercept is going to be 3. Then I'm going to work out what this asymptote is going to be. So let's just consider for a moment what the graph of y equals 2 to the x would look like. The asymptote for y equals 2 to the x is the x-axis, and as the graph has moved down 5 places, therefore our new asymptote will be y equals minus 5. Okay, so I'm now going to sketch that, and you can see I've got my x and y axis, and there's my graph. Don't worry if you can't get the nice smooth curve, as long as you're showing the y-intercept and that equation of the asymptote there. Make sure you label your x and y axis. That's the key points. Now this allows us to look at the domain. Well, we know the domain works for all those x values, so we say r, real numbers. The range, however, is all those values above this asymptote. So we say that the range is greater than minus 5. Or we can write it as minus 5 towards infinity, positive infinity. My final example is going to be using our class pads or our calculators to solve this equation. So we're solving 2x equals 15. So